Good morning, all of you. So today we will see graphs in case of convex lens. And that are for convex lens. So first graph is U versus V graph. These graphs are coming same like mirror, which we have already learned. If suppose I am taking U on x-axis and V on y-axis, then in this case the graph will come like this. And if we will draw here one perpendicular at this point, actually not perpendicular but just making angle 45 degree, with the x-axis. And just these two perpendiculars. And if suppose we want to find focal length from this graph, then this focal length is given by f is equal to OA plus OB divided by 4 from U versus V graph. Same like your mirror. Next graph. So that is 1 by U versus 1 by V graph. One by U versus 1 by V graph. This graph is coming like this. And if suppose it is cutting to the x and y intercept at point, let us suppose B and A, and this is O, that is origin, then focal length from this graph f is equal to 2 divided by OA plus OB. So whenever they are giving you graph, which graph they are giving, you just check it, and from that you can find out this focal length. Okay, understood? Now next, let's move ahead. It's Very important topic, that is lens makers formula. Very important for competitive exam. Keep it in mind. This is very important. Again, I am repeating lens makers formula. Lens makers formula. So for that, first I am drawing the diagram. This is the lens. And this is the principal axis. Now, assume that object is here. This is his object O at this point. Then this light ray is coming from here. Yes, and image will form here. This ray I have drawn another ray. You can see this I will denote with dotted line. This is nothing but, if we will consider separately, then there are two refracting surfaces. This is one refracting surface, this is another refracting surface. So because of this first refracting surface, you are getting image here, and that is what your image, that is I1. This is what I1 image at this point, and this is your image, that is I2. This image is I2, that is final image, we can say. Actual ray will go like this. Okay. And this one is focus. This is F, and here is this F. Now this distance is U. That is object distance. And this one where you are getting image I2, and this one where you are getting image I1, I am representing it as a V and V1 respectively. This is V and this is V1. Now for this surface you are having radius of curvature, that is R1, and this one is having radius of curvature R2. So it is not equiconvex. It is not equiconvex. This is biconvex because R1 is not equal to R2. Okay. Now this is medium 1. Medium 1. So its refractive index is what? Mu1. And this is inside the lens, that is medium 2. So therefore its refractive index is mu2. Now we know for curved refracting surface, for curved refracting surface. Already I told you the formula. You can, if you will see in the notebook, you will get this. For curved refracting surface, you are having formula mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. Yes, this is what common formula. Right or wrong? We don't know this. Yes, right. This is formula already we have derived. Now, from diagram, see here, from diagram, for first surface, for first surface. Now see here, for first surface means this surface. So you are having u is u, yes, and v is what? v1, because this is I1 image formed because of this first surface. Because of this first surface, we are not taking the complete lens in the first case. We are taking first how the image is getting formed because of this first refracting surface. That's why this is I have noted with I1 and its distance is v1. So therefore, what you will get, mu2 by v1 minus mu1 by u is equal to mu2 minus mu1 divided by r1, because it is for first refracting surface. So let's call this as equation number 1. Got it? Okay, understood. This is for first refracting surface. Now next, for second surface. Now for second surface, what we are getting, mu1 by phi minus mu2 by phi1, because now u is this phi1 is there, no, this image is formed. This is what object for the second surface. Keep it in mind. O is object for first surface, I1 is object for second surface. Okay, shall I write that also here? Wait, I will make one box here and I will write so that you will understand what is happening here. O is object for first surface, and because of this first surface, I1 is image, or I will write in a simple language. Wait, how I am writing, see, just I will write like this. O is object and I1 is image for first surface, for first refracting surface. Next one, now I1 is object, I1 is object and I2 is image for what? For second refracting surface. That's why in the formula, if you will see carefully, this is for second refracting surface. That's why if you will see this formula, mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. Here at the place of v, I have kept v1 because for the first surface, v1 is the image distance. And at the place of u, I have kept u because this O is object for the first refracting surface. Similarly, for second surface, in this formula only you see this. Now here it is again mu1 because mu2 is medium 1 now and mu1 is medium 2. That's why at the place of mu2 I have replaced mu1, and image distance is what here, v. So that's why v minus, this is medium 1 now for this, so that's why mu2 by v1, and this is equal to what we are getting, mu1 minus mu2, mu1 minus mu2 divided by r2. So let's call this as equation number 2. Understood? Okay. Now what we are doing, see, we are adding equation 1 and 2. So let's move to the next page. So let's add this. Finish writing? Okay. So adding equation 1 and 2. What we are getting, see, mu1 into 1 by v minus 1 by u is equal to mu2 minus mu1 into 1 by r1 minus 1 by r2. After this, what I am going to bring, I am transferring this mu1 here. So this 1 by v minus 1 by u as it is. This mu1 I am transferring here, so it will go at denominator mu1, and this part is as it is, 1 by r1 minus 1 by r. Okay. Now this 1 by v minus 1 by u is what? 1 by f, from Lenz's formula. So therefore 1 by f is equal to, this one I am separating, mu2 minus mu1 minus this mu1 by mu1 is what? 1. Yes or not? After separating the numerator, denominator, and into bracket 1 by r1 minus 1 by r2. This formula is very important, which you have to keep it in mind. That is what? Lenz maker's formula. What is this? Lenz maker's formula. Okay. So now some note point I am giving. Some note point which are very important while using this formula. So see here, note. This note is very important. Note point. First I am taking, that is equi convex lens. Equiconvex. Equiconvex means what? You know, equiconvex means R1 is equal to R2. So here this is what? R1, this is R2, and that is also equal to R, and this is also equal to R. So R is equal to R1 or R1 is equal to R, R2 is also equal to R. Then only we can say that it is a equiconvex. So R1 is equal to R and R2 is also equal to R. Okay, this is equiconvex lens. Now if we will substitute here R and R, 1 by R minus of minus 1 by R, so it will become 2, minus 2. Yes, so if we will substitute and do, what we will get? We will get, after this substitution, F is equal to R divided by 2 into mu minus 1. This formula turns like this. Okay, next one, next node point, that is for second node point I am telling, that is for plano-convex. If lens is plano-convex, so if lens is plano-convex, you know how it will be. One side will be plane and another side will be something like this. Like this. Okay, this is a plano-convex. So here R1 is equal to what, ray? R1 will become infinity. Why? Because it is a plane surface. R1 is equal to infinity for this surface, and R2 is equal to, let us suppose, R. So this is minus R, obviously, है ना? So here also minus R. Keep it in mind. What is that? Minus R. Because from sign convention. So always you keep this also. Otherwise, again, while using formula, you will forget what to use. So you substitute here minus R only. Now only I am telling, and write now only minus R, so that there is no confusion again. So these node points are very important. So here also R2 is what? Minus R only. So let us suppose this is minus R. Then if we will substitute this, you will get F is equal to R divided by mu minus 1 for plano-convex. Next one, third node point. So third node point, you see, this is a third node point for equi-concave lens. I think space is not sufficient. We will go for next page. Okay, this one I am keeping on next page. First, note down this two. Noted. Let's move ahead. Note point number 3. So this is note point number 3. Equi-concave lens. equiconcave. So equiconcave means how you know. So this is equiconcave lens, and here now use sign convention properly. How to determine? See, this is a one surface now. This is one curved surface. So here it is a center of this particular square. If we will see, and for this also, when you are solving problem, you keep it in mind. This is your optical center or center of curvature, we can say. So you are measuring from this to here, and from this to this side, and light is falling from this side. So therefore, here, if this is optical center, you are going to measure here. So which is opposite to the direction of light, है. So here R1 is equal to minus R, R2 is equal to plus R. Okay. So for this, R1 is equal to minus R, and R2 is equal to plus R. R2 is equal to plus R. And for this focal length, F is equal to minus R divided by 2 into mu minus 1. Next one is plano concave lens. That is fourth node point. So if lens is plano concave lens, plano concave lens. This is plano concave lens. And now for this, R1 is equal to infinity. For this surface, R1 is equal to infinity, and for this R2 is equal to R, that is plus R. So in this case, if you want to find focal length, direct formulas I have given in the node points. So keep it in mind. F is equal to R divided by 2 into mu minus 1. Okay. So these are the node points which will help you in lens maker's formula in various cases. So you have to keep it in mind which lens he is giving, equiconvex or different radii means this formula. If equiconvex, plano convex and all these things are there, then you can use this type of formulas for quick answers. Right? Finished? Note down. Okay, finished. So one more formula I am giving, that is called Newton's formula. Newton's formula. Suppose now I am having a lens. Let us suppose this is a lens. Okay, and this is its principle. Shall I take on next page? Okay, wait. I will take on next page. This part. Okay. So see, that is Newton's formula. Suppose now this is a lens and this is principal axis, and now this is a focus. Okay. So for this lens, this is a focus. Right. So if you want to find focal length of this lens, and suppose here is an object like this, and here you are getting image, then whatever the distance from this focus of object is x1, and from this focus to image is x2, then the focal length is what? F is equal to x1 by x2. What is focal length? F is equal to under root x1 x2. F square is equal to x1 into x2. So this formula is for focal length. So that is F is equal to under root of x1 into x2, where x1 is object distance from focus and x2 is image distance from focus. So whatever the Newton sign conventions are there, in that distances should be measured from focus. So that's why x1 and x2 are the distances of object and images from the focus respectively. So this formula we just keep it in mind. Okay. So I will send you one assignment, 5-10 problems on this lens makers formula. You just try to solve it. Okay. So bye for today.